In this lecture, we will see the purpose of using state in Terraform. We already saw how Terraform uses a state file to map the resource configuration to the real-world infrastructure. This mapping allows Terraform to create execution plans when a drift is identified between the resource configuration files and the state. Hence, a state file can be considered to be a blueprint of all the resources that Terraform manages out there in the real world. When Terraform creates a resource, it records its identity in the state. Be it the local file resource that creates a file in the machine, a logical resource such as the random pet which just throws out the random pet name, or resources in the cloud. Each resource created and managed by Terraform would have a unique ID which is used to identify the resources in the real world. Besides the mapping between resources in the configuration and the real world, the state file also tracks metadata details such as resource dependencies. Earlier, we learned that Terraform supports two types of dependencies, the implicit and the explicit. If we inspect the example configuration file, we can see that we have three resources to provision here. The local file resource called pet depends on the random pet resource. This is evident from the content argument in the local file resource block that uses a reference to the random pet resource. The local file resource called cat is unrelated to the other, and hence it can be created in parallel with the random pet resource. When we apply this configuration, the random pet resource called myPet and the local file called cat can be created first, at the same time. But the local file resource called pet can only be created after the random pet resource is created. We can see that the local file with the name cat and the random pet resource with the name myPet are the first resources to be created. Once that is done, only then is the local file resource called pet created. Until now, we do not rely on state for the provisioning. But what if we decide to delete the random pet resource and the dependent local file from the configuration? Let us now look at what happens when we remove resources from the file. For example, we remove the local file and the random pet resource from the file. If we were to apply the configuration now, Terraform knows that it has to delete these resources. However, in which order does it delete it? Should it delete the random pet resource first or the local file? The information about the resource dependency is no longer available in the configuration file as we have removed those lines from it. This is where Terraform relies on the state and the fact that it tracks metadata. Within the state file, we can clearly see that the local file resource called pet has a dependency on the random pet resource. Since these two resources have now been removed from the configuration, Terraform now knows that it should delete the local file first, followed by the random resource. One other benefit of using state is performance. When dealing with a handful number of resources, it may be feasible for Terraform to reconcile state with the real-world infrastructure after every single Terraform command, such as plan or apply. But in the real world, Terraform would manage hundreds and thousands of such resources. And when these resources are distributed to multiple providers, and especially those that are on the cloud, it is not feasible for Terraform to reconcile state for every Terraform operation. This is because it would take several seconds to several minutes in some cases for Terraform to fetch details about every single resource from all the providers which are configured. For larger infrastructures, this may prove to be too slow. In such cases, the Terraform state can be used as the record of truth without having to reconcile. This would improve the performance significantly. Terraform stores a cache of attribute values for all resources in the state. And we can specifically make Terraform to refer to the state file alone while running commands and bypass having to refresh state every time. To do this, we can make use of the -refresh is equal to false flag with all the Terraform commands that make use of state. When we run the plan with this flag, you can see that Terraform does not refresh state. Instead, it relies on the cached attributes, and in this example, the content which has changed in the configuration file. And as a result, the execution plan plots a resource replacement. The final benefit of state that we are going to look at is collaboration when working as a team. As we have seen in the previous lectures, the Terraform state file is stored in the same configuration directory in a file called terraform.tfstate. In a normal scenario, this means that the state file resides in the folder or a directory in the end user's laptop. This is alright when starting off with Terraform, learning and implementing small projects individually. However, this is far from ideal when working as a team. Every user in the team should always have the latest state data before running Terraform, and make sure that nobody else runs Terraform at the same time. Failure to do so can result in unpredictable errors as a consequence. In such a scenario, it is highly recommended to save the Terraform state file in a remote data store rather than to rely on a local copy. This allows the state to be shared between all members of the team securely. Examples of remote state stores are Amazon Web Services S3 service, HashiCorp's console, and Terraform Cloud. We will learn more about remote state stores in much more detail in a later section. We will also learn about Terraform Cloud in a separate section of its own. Now, let's head over to the hands-on labs and explore working with Terraform State.